All right, let's dive right in. Today, we're talking about two of the most fundamental tools in any Python programmer's toolkit, variables and comments. But we're not just going to go over the dry syntax. Nope. We're going to get into how you can use them to write code that's not just for the computer, but for other people, and you know what? Most importantly, for your future self.
Oh man, we have all been there, right? You write this amazing piece of code, you feel like a total genius, and then you come back to it maybe 2 weeks later, and you have absolutely no clue what you were thinking. This quote from the dev community just hits the nail on the head. So the whole point of this explainer is to make sure your code never feels like a puzzle again.
And this gets us to a really core principle in software development. Code is read way, way more often than it's written. Just let that sink in for a second. Every single line you type is a form of communication. It's telling a story about your logic, your assumptions, and what you were trying to do. Making that story crystal clear is what really separates a good coder from a great one.
So how do we add that extra layer of context to our story? Well, our first tool is the humble comment. I absolutely love thinking about comments as the director's commentary on a movie. The movie itself, your program, it runs exactly the same whether the commentary is on or off. But that commentary gives you all that priceless behind-the-scenes insight, explaining why certain decisions were made.
Think about it this way. Every comment you write is basically a letter to your future self and to your teammates. They're there to explain the why behind your code, not just the how or the what. You can use them to flag a tricky part of an algorithm, to make it easier to hunt down bugs later on, and to make sure that anyone else who looks at your project can get up to speed without having to reverse engineer your brain. The most common type you'll use by far is the single-line comment. Anything on a line that starts with that hash symbol, a hashtag, is completely invisible to Python. It will not be executed. Its only purpose is to be a note for the human who's reading the code. It's simple, it's direct, and you'll be using it constantly.
But what happens when one line just isn't enough? What if you need to write a longer explanation, a note that takes up a few lines? How do we handle that in Python?
Okay, this is where we need to talk about docstrings, and this is a really, really important distinction. A docstring isn't just a comment. It's a special string, wrapped in triple quotes, that becomes the official built-in documentation for a function or a class or a module. Now here's the key. While you could technically use triple quotes for any old multi-line comment, their real professional purpose is for creating documentation that other tools and other developers can actually access and use.
And wow, this slide just illustrates the difference perfectly. The example on the left, it's so vague, it's basically useless. But the one on the right, that's a professional contract. It tells you exactly what the function does, what arguments it needs, and what type they are, and what it's going to give you back. This right here is the hallmark of high-quality, maintainable code.
So let's really break this down. A block of hash comments explains some tricky bit of logic inside a function. A docstring, on the other hand, documents what the function is for the entire outside world. And here's the big difference. Python completely ignores the hash comments, but it actually stores the docstring and makes it accessible while the program is running. That's why the best practice, the truly Pythonic way to do it, is to use docstrings only for documentation at the start of a function or class, and use multiple lines each starting with a hash symbol for a regular old block comment.
All right, let's shift gears. If comments are the notes in the margins, then variables are the main characters of our code story. The absolute easiest way to think about a variable is like a labeled box where you can store a piece of information.
A little more formally, a variable is just a name that points to a value that's being stored in memory. So in this example, my age is the label we're putting on our box. That equal sign, that's the assignment operator. It's what actually puts stuff into the box. And 20 is the value itself. Now, whenever we use the name my age in our code, Python knows we're talking about the number 20. Simple as that.
Let's play this out in a quick little scenario. Imagine you're building a game, and you need to keep track of the player's score. So you create a variable, our labeled box, call it score, and you put the number 100 inside it. But then something happens in the game. Your player finds a power-up, and obviously their score has to change. So we just use that same assignment operator again to put a new value into our score box. This is called reassignment, and it's what makes variables so dynamic and powerful. The old value, 100, it's gone. From this moment on, score now points to 150. Now, you can name your variables almost anything you want,
but that definitely doesn't mean you should. The Python community has this shared style guide called PEP 8. I love this analogy. Think of it as the fashion guide for Python code. It's not about strict rules that will break your code, but about conventions that help everyone's code look clean, consistent, and professional. And it's so important to separate the hard rules from the style conventions. The rules on the left, Python enforces those. If you try to start a variable name with a number, your program will crash. End of story. The conventions on the right, well, if you name a variable username instead of user underscore name, your code will still run. But you're kind of breaking the social contract and making it harder for other Python developers to read. It's all about making the code predictable and easy to understand for everyone.
And one of the most important conventions in that style guide is snake case. Whenever you have a variable name made up of multiple words, you just make it all lowercase and separate the words with an underscore. It's simple, it's clean, and it makes your code immediately readable to any other Python dev out there.
Oh, right. So what happens when we inevitably get a name wrong? Because it will happen. Let's look at one of the most common errors that every single developer, from total beginner to seasoned expert, runs into, the dreaded name error.
Take a close look at this code. We create a variable, our little box labeled greeting, and we put the text hello inside. But when we try to print it, we make a tiny little mistake. Can you spot it? Yep, we accidentally typed grading instead of greeting. And this is what Python gives us back. It raises a name error. But look at how helpful that message is. It doesn't just crash, it tells you the exact name it doesn't recognize, greeting, and then it even suggests what you probably meant to type. Python is actively trying to help you fix your own bug. How cool is that? So when you see a name error, don't panic. It almost always boils down to one of two simple things. Either you've got a typo in the name, just like we saw, or you're trying to use a variable before you've actually put anything in its box. Just check your spelling and check the order of your code. So the huge takeaway from all of this is that writing good code is really an act of communication. Great comments that explain the why and descriptive variable names aren't just extra chores to do at the end. They are fundamental skills. They make your code self-documenting, and that saves everyone, including you, hours of confusion down the line. They are, quite simply, the signs of a professional developer. And that leaves us with a final thought. Every time you finish a piece of code, ask yourself this question. Are you leaving behind a gift that's easy for the next person to understand and build upon? Or are you leaving behind a frustrating puzzle that they're going to have to solve? The choice, as always, is yours.